sixth grade has a pretty exciting variety of projects that I think everybody will enjoy. And we are going to start with this presentation, Gordon's project of Does Age Affect Memory? Okay, Gordon, go ahead. Tell us about your scientific method, what you found, what you learned.
Okay, so the research question is, does age affect memory? Okay, some background information for this. Hormones and proteins, which save brain cells and raise neural growth, get worse the older you get. So a lot of older people, less blood flows to the brain, which weakens memory and changes to your main skills like remembering. Okay, I got that from Google. Another source would be this one. So your brain's volume stops in your early 20s and slowly shrinks for the rest of your life. When you're 40, a lot of people start to notice their ability to remember new information like that. If over time starts shrinking, nerve cells, neurons can shrink or slowly get worse, and the connections of neurons get a big shrink. A regular aging brain gets lower blood flow and gets another source would be this. Some brain areas shrink. I'm not sure. Myelin, she surrounds and protects nerve fibers, which gets worse, which slows the speed of communication between neurons. Some of the receptors on the surface of neurons that make communication possible get worse, which can make learning new stuff and remembering stuff different. Right side, the branching of dendrites gets bigger and connections between far away get stronger. This allows the brain to see the bigger picture and to understand implications of specification. Kind of hypothesis is, if you are older, then your memory will be worse because memory. These are the materials that you start memory flashcards. The procedure was to make flashcards and play them in 5 different age groups. This is the age group, and then how long it took for them to complete the memory game. For the age group of 10 through 19 was 1 minute and 20 seconds and 20 milliseconds, and 1 minute, 27 seconds and 9 milliseconds. For the 20 through 29 group, was 1 minute and 67 milliseconds, and 1 minute, 59 seconds, 95 milliseconds. The 30 to 39 age group was 0 minutes, 49 seconds, 84 milliseconds, and 44 seconds, and 71 milliseconds. So my hypothesis is sort of right because it depends on what type of memory you're using. And my conclusion would be that it depends on the person and age, but the memory that you're better at using changes as you get older, and I would get more people next time because we finished it. I'm done.
Okay. Okay. Okay, Esther, it looks like you need a second to get your presentation ready while you're doing, to pull it up. While you're doing that, do you want to tell us a little bit about your presentation, or you want to wait to see what comes up on the, what you have on the slideshow? Okay. Okay. So again, welcome to everybody. We have begun part 2 of our virtual science expo. We are in the 6th grade room right now. We just heard from Gordon with a study about how age affects memory. Gordon found that his hypothesis was partially supported. And Gordon, I would be excited to see what additional research would would confirm that or take your research in a different direction. Okay, so now we have Esther, who will be presenting her project as soon as we get it up on the screen. Okay. Okay, Esther, nice and loud.
Alright, does it float? Wait, should I keep that? Alright. What causes buoyancy? Pressure exerted by the fluid in which an object is immersed is what causes buoyancy. I was reading on the website askamathematician.com. It explained to me the principles of buoyancy. So normally things would just fall, but if there's a fluid in the way, then everything needs to be rearranged. Take something heavy, for example, like a rock or metal, then drop it in water. Rock will sink and the water will go up. Although there is some mass, the water being moved up, the object with bigger mass, the rock, is moved lower, so the water has to go up. Buoyancy is an object that is able to float in fluids. Not all objects have buoyancy. Buoyancy is caused by the pressure exerted by the fluid in which an object is immersed. The discovery of buoyancy is credited to the Greek mathematician Archimedes. He was comparing the weight of the king's supposedly gold crown with other objects. So he dropped the crown in water, but he noticed that a few gold coins were faster to sink to the bottom than the crown. There are 3 types of buoyancy: positive, negative, and neutral.
Why don't you stand up by the board? You can tap the board and we'll advance the slides. That way people can see you while you're talking about your project.
All right, positive buoyancy. Positive buoyancy occurs when an object lighter than the fluid it displaces. The object will float because the buoyant force is greater than the object's weight. A swimmer experiences a great amount of buoyant force. The Dead Sea in Israel is famous for positive buoyancy. Negative buoyancy. Negative buoyancy occurs when an object is denser than the fluid it displaces. The object will sink because its weight is greater than the buoyant force. A submarine is designed to operate underwater by storing and releasing water through ballast tanks. Neutral buoyancy. Neutral buoyancy occurs when an object's average density is equal to the density of the fluid in which it is immersed, resulting in the buoyant force balancing the force of gravity that would otherwise cause the object to sink. Hypothesis. If I place an apple, sponge, and tub of water, then these objects will float because the objects have less mass than the water does. So the buoyant force is pushing them up. The apple will probably sink more than the sponge because it has a bigger mass. So materials: apple, wood, sponge, rock, marble, coin, bucket with water, and toy ship. So my procedure was to weigh the apple, wood, sponge, rock, marble, coin, and toy ship, place it all in water, see if it sinks or if it floats, record data, and see why it floats and why it sinks. So I'm going to weigh the items and place them in water. I will see which items float and which items sink and how far deep they went in the water. Then I'll write it down, and after that I will explain why these items float and why they sink. So did it float? The apple floated, the wood floated, the sponge floated, the rock didn't, the marble didn't, the coin didn't, and the stick didn't. So how far did it go? The stick went in 1/2 centimeter. The sponge went in 1/2 centimeter. The boat went in 1 centimeter. The apple went in 7 centimeters, and the other sank to the bottom. So part of my hypothesis was correct. The items that I said did float, but I assumed that the wood would sink because I thought that it had less mass than the water, so it would sink. Actually, the water had more mass than the piece of wood, so the wood floated. So conclusion, what I would do differently. In conclusion, many objects have buoyancy and many don't. Whatever has more mass than the water sinks, and if the water has more mass than the other objects, the objects will float. If I had wanted to use larger objects, then I would have placed them in a pool, but just because there is more water does not mean that the water has any more mass than the bucket of water. I think that's it.
Okay, awesome. Esther, what additional things would you want to test for buoyancy? Think about what you might do next.
Probably pool floaties
Okay,
and see why they float and other heavier things.
awesome. Okay, good job, Esther. Okay, who do we have up next? I'm gonna see if we can work on sharing Esty. Okay, let me just join the Zoom room from here so we can project it onto the screen. Hang on 1 second. Okay. Okay, go ahead, Esty. We're going to get you set up so you can share it onto the screen as well. You ready? Okay, so let's go back into the Zoom screen so we can share. Go for it, Esty.
So my project was on matching voices to faces.
Okay, a little louder.
My research question was how many people can accurately create a picture of a person just by their voice. There's a recent study that has proven it's possible for people to conclude how others look merely by hearing their voices. According to Harriet Smith, a doctoral student in psychology, there is enough overlapping information that they can match strangers' voices and faces with relative accuracy. Smith asked participants to listen to a voice and then match it with a face. The group of participants achieved this task with 60% accuracy. Researchers were surprised at how often clues from someone's voice and face can administer related information. Although we were expecting there to be more overlapping information, there to be some overlap information offered by faces and voices, we were surprised about the strength of the relationships themselves. When one hears a voice on the phone or in any case, when they don't see the face voice belongs to, one will naturally make some assumptions about the person whose voice they're listening to. Researchers are discovering that one's voice can reveal a decent amount of their conditions, including their height and age. According to a study displayed at the 2013 Acoustical Society of America meeting, a person's height can become clear by merely hearing their voice. Just around 2/3 of the time, volunteers who heard a few lines spoken were able to determine the taller of the two speakers. Volunteers were also able to put a group of 5 people in order according to people's age, heights, according to the people's heights with reasonable accuracy. One guide in deducing height may be found in how deep the person's voice is. In general, taller people ordinarily have deeper voices. Nevertheless, there may quite possibly be other factors that contributed to reducing person's height.
Esty, you want to jump to your hypothesis? Excellent.
So my hypothesis is if there is a correlation between a person's voice and their appearance, then people will be able to accurately match a stranger's voice to their face because people will be able to create an accurate image in their mind just by hearing the stranger's voice. So I need a camera and a voice recorder, tape measure, like a tape, and a computer. And so I have to find subjects that you can record their voice and take a picture of them. Record the subject saying something. It's preferable that you have them all saying the same thing. Take a picture of their face. Number the recordings and pictures to match. Find test subjects. The more the better. Make sure the test subjects do not know those that you're recording the picture of. Leave the pictures of the people out. Pick one of the test subjects. Pick a voice and have the test subject listen to the voice. Have the test subject write down / tell you which face that voice matches to. Repeat Steps 7 and 8 for each test subject. Record the data and analyze the data. And for question number 1, 4 of 18 people got this correct. Question number 2, 10 out of 18 people got this one correct. And question number 3, 11 out of 18 people got it correct. And 1 out of 18 people got this question. And 5 out of 18 people got 5 correct. And 13 out of 18 people got number 6 correct. And 3 out of 18 people got 7 correct. 4 out of 18 people got 8 correct. And so 22.2% got the people got the first question correct, and 55.6 got the second one.
Excellent.
My hypothesis was incorrect because only 35% of the people tested were able to accurately guess which face matched to the correct voice. And in conclusion, my hypothesis was incorrect. In the future, I may try to use more test subjects. I may try to figure out if the age of my test subjects will make a difference. I think it would be interesting to see if the younger test subjects accurately matched more of the faces with voices or vice versa. I may also try to take pictures of older people and younger people separately to see if the age of the person makes it easier or harder to guess which voice matches.
Okay. Excellent, Esty. Thank you. All right. We'll stop the share for a second so our next presenter can find his information. Again, welcome everybody. We're here for our 2021 Virtual Science Expo. We are in the 6th grade right now. We've already heard from 3 of our projects. We heard a project on age and memory, and we then saw a project on buoyancy, and third, we saw a project on matching voices with faces. Our scientists have been getting some stuff correct, but some of their hypotheses have been incorrect, which is always an opportunity for additional studies. So good job, everybody, for recognizing that sometimes our hypotheses are not on the mark. And I can't wait to see what other science projects come from your data. Okay, so click on the drive. Okay, so let's go back to the Zoom so we can share the screen so people can see. And share screen. Right here. Excellent. Okay, nice and loud, Ilan.
So I did the carbon dioxide fire extinguisher. My research question was, will adding more baking soda affect the result and how? My background information, why does baking soda react with vinegar? It reacts because one is a base and the other is an acid. Acids and bases each have different parts of water. Baking soda is sodium
Bicarbonate.
Base, and vinegar is made weaker acidic acid when they react and to release the OH and HB water, they will release carbon dioxide. My hypothesis, if you use more baking soda, then the flame will go up faster because baking soda will cause the reaction to go faster. Material, baking soda distilled white vinegar, matchstick, lighter, candles, and clear picture. I had to put a clear container on the cookie sheet and pour some vinegar in the container with the baking soda. It's your phone. Pour some vinegar to the container with the baking soda. Let the reaction and the foaming calm down while you light the candle. Hold the container next to and above the flames. Slowly tilt the container and pour the gas from the container onto the flames. Don't pour the liquid, the candle flame is normal. I'm going to record my data with a bar graph. I on the y-axis, it will have how much time does it take, and I mean on the x-axis, how much time does it take, and on the y-axis, how much baking soda will be put in. With half a tablespoon, it was 1 second. 1 tablespoon, it was 2.5 seconds, and 2 tablespoons, it was 3 seconds. My hypothesis was incorrect. My conclusion on what I would do differently: the less baking soda, the faster it goes. I think that my hypothesis was incorrect because baking soda was weighing it down. And that's it.
Okay. Good job, Elon. Excellent. Okay, who do we have up next? Hodaya. Okay, a little teaser for one of our upcoming presentations. Cups with different colored liquids. So let's go back to the Zoom so we can share. So we can share. Mhm. Okay, go for it.
Okay, does sugar affect test results? Hypothesis. If a child eats a sugary diet, then they will get a worse grade on tests because they will be hyper. If a student maintains a normal diet, then they will get the best grade because they are used to eating that way. Background information. In my experiment, I will test 3 people of 3 diverse diets: sugary, healthy, and normal. I will then give them a test to see if sugar affects their grades. Some say sugar can raise your blood sugar to the point where it can affect test scores. But is this true? This experiment will test that theory to see how sugar really affects test results. Several studies have suggested that consuming glucose before taking tests may increase scores, says Nibur.com. Research question. Does sugar really make you hyper? In this experiment, you will see if sugar really affects test results. Materials. Sugary foods, healthy foods, and people. Procedure. Have one person eat a sugar diet for 1 day, one person eat a healthy diet for 1 day, and a normal diet for 1 day. And make sure you record everything they eat, and then give them a test. And I recorded my diet by charts. This is Sugar's diet,
Keep going.
which is
That's okay.
2 servings cereal, Sprite, 2 small bags of cookies, chocolate, ice cream, juice, hot cocoa, and 2 Kit Kats. And Normal's diet was a cinnamon muffin, water, 1 slice of pizza, 2 small apples, 2 flatbreads, 1 roll, 1 bag of popcorn, and 1 serving. So on the diet, the students scored as follows: Healthy got 77 full scale IQ, Sugar got 72 full scale IQ, and the second test subject for Sugar got 75, and Normal got 109. And this was on a regular day basis. The test results of the students: the Healthy got on a regular day basis, the Sugar got 91, the second Sugar got 92, and the Normal got 102. So was my hypothesis incorrect or correct? I believe my hypothesis was correct. The Normal did better on the test because they were on a normal diet, and everyone else got better test scores on a normal diet than on the one that was altered. Normal diets work best for tests. Conclusion of what I would do differently. In conclusion, after seeing a 16-point improvement in one student after they went back to a normal diet, I think this proves my point. Sugar is not a great thing to have before tests. As for the best diet, normal, I definitely could at 109. Healthy had 77, got 75, and 72. The normal diet had the best score, but healthy still reigns supreme over the sugar diets. In the future, I would try to give my sugar students more sugar and my healthy students more health, so that they're completely sugar and healthy before tests. Okay, that's it.
Okay, good job. Very interesting. I want to see more follow-up on that. Okay, Lisa, you're pulling up your slideshow?
Yeah.
Okay, and then you're gonna tell us about these cups over here?
Yeah, that's just for the class because I'll type in.
Okay,
I'm just getting it now.
okay. So now let's go back to Zoom so you can share that. Okay. Okay, Elisa, before we get started again, welcome everybody. We are still in the 6th grade room. We will be going to the 5th grade room shortly.
So I did edible water bottles. And so my research question was, can we make edible water bottles bigger by using more calcium lactate? Okay, so my background information is that more than 8 plastic bottles in the sea each year. And it's estimated that in the year 2050, there'll be more plastic than fishes in the sea. So that's why people are starting to, that's why people created edible water bottles so that we will have less pollution. Okay, so if we use calcium lactate, so my hypothesis is if we use more calcium lactate, then it'll be bigger. So my materials were water, so 1/4 teaspoon of sodium lactate, 1 teaspoon of calcium lactate, a large bowl, a smaller bowl, a hand mixer, and 1 teaspoon. Okay, so the procedures are long. So basically, you take 1/4 teaspoon of sodium alginate into 1 cup of water and use a hand mixer to mix it until it's white. Then you have to wait for 15 minutes so that there won't be any air bubbles when you make the water bottle. Then in a large bowl, you stir 1 teaspoon of calcium lactate into 4 cups of water. And you want to mix it well so that the calcium lactate will dissolve. And then you use your tablespoon to scoop the sodium alginate solution and gently drop it into a bowl of water, into the bowl containing sodium lactate, the sodium lactate solution. It'll leave the ball of water. You can drop more spoonfuls in, but you have to make sure that they don't touch, otherwise they'll stick together. Then you should dip it in. Then you should take out the balls of water and dip it into a bowl of water so to stop the reaction, and then you can eat them after you take them out. So I record my data with pictures. So I did use 3 other drinks, which were a purple drink, Kool-Aid, and iced tea. But if the drinks that you use are acidic, they'll ruin the barrier of the that's keeping the water in. So over here, they're showing these tablets that I dipped into these cups of water, and it shows their acidic value and why I couldn't use them. And why they destroyed my thing, which is somewhere here. So they'll be there. So my hypothesis is incorrect because it's not the calcium lactate that creates the bubble, it's the sodium alginate solution that creates it. So these are the drinks that I used. So yeah, this is a purple drink because I didn't know what to do. Okay. So yeah, they're all bad because they're all way too acidic. Okay, so this is the acidic value chart. So if I got when I dipped in these tablets, they were all around this area of acidic values, so I couldn't use them because they were 3, 4, and 5. Yeah.
Excellent.
So
Okay. Okay, so let's come over here. Just gonna click stop share.
I'm just gonna do that. So.
Okay. Okay. Thank you, sixth grade, for some really exciting research. I am. Okay, everybody can definitely wave to the camera, to anybody. Okay, we are going to move on to the fifth grade now. Thank you, Ms. T. We'll see Ms. Trogett again a little bit later with the seventh and eighth grade. And thank you again.
Always do you help pass them down?
Okay, welcome everybody to the fifth grade room. We have a few different projects